This video is for Chapter 7, assignment number 2 on solving trig equations. So this is problem number 8 from the textbook, page 492, and I'm just going to show how to do the problem. So first we want to isolate the cosine, so I'm going to subtract 1 from both sides and get that negative cosine theta is equal to negative 1/2. And cosine theta equals positive 1/2. So at this point you have to figure out whether there is a triangle in the diagram or whether this value would be found on the axes. And since cosine is x over r, then we know that x is equal to 1 and the r is 2. It's one way to think of that. So we want to figure out that that is a 30, 60, 90 triangle with the x leg being 1. And since it's positive 1, that means that it's going to be in the first quadrant. We'll get a line. Something about like that, where the x is 1 and the r is 2, so it's a tall triangle in the first quadrant, or a tall triangle in the fourth quadrant. Okay, so then the sides here, this side is 1, which works for both triangles, and the hypotenuse is 2. Now we know that the long side is root 3, because it's the special right triangle 1, 2, root 3. But we don't need to put that in the diagram because what we really want to know are the angles to this point. So if this is a 60-degree reference angle, then this angle here is pi over 3. That's measuring starting from standard position, rotating to this ray. And then this angle all the way over here is 5 pi over 3. So those are two solutions to the equation. And then you just need all of the solutions. So two of the solutions are pi over 3 and 5 pi over 3. And then the rest of them are plus 2 pi k, where k is any integer. So any angle that is coterminal with pi over 3 will solve this equation. And any angle that is coterminal with 5 pi over 3 will solve this equation. So it doesn't matter whether you're at pi over 3 or an extra lap around the circle or another lap or another lap, any of those will solve the equation. Then it would be a good idea to put this equation into Desmos and see how these equations work out that way. So here we are in Desmos, and you can type in the original equation, which was 1 minus cosine theta. So y equals 1 minus cosine theta, or let's use x, and then the next equation is y equals 1/2. And we want to know where these points of intersection are. I think it's kind of nice to see the x-axis scaled in terms of pi and find these values. So according to our math, there's supposed to be one at pi over 3 and at 5 pi over 3. So you can see them both there. And then you can see the next ones are here and here. And if you add 2 pi to pi over 3, you would get 11 pi over 3. Oh, wait, nope. If you add 2 pi to pi over 3, you would get 7 pi over 3. And if you add 2 pi to 5 pi over 3, you'd get 11 pi over 3. And then these are the next ones, adding 2 pi yet again. So anyway, I think Desmos is a great way to check to see whether your solutions are reasonable and help you visualize what your solutions to the equation represent. All right, next problem, number 9. 4 cosine squared theta is equal to 1. So first we want to isolate the cosine squared, so I'm going to divide both sides by 4. So cosine squared theta equals 1/4. And then cosine theta equals plus or minus the square root of 1/4. And cosine theta equals plus or minus 1/2. So there are actually 4 positions around the circle where cosine could equal positive 1/2 or negative 1/2. We already have 2 of them right here, so I'm going to put those in from the last problem. So there's one of them. There's another. And then there's 2 more over here because the negative ones count as well. So here the sides of the triangle are negative 1/2 and negative 1/2. So here the cosine values are both negative. Oops. 1/2, and in these quadrants the cosine values are positive 1/2. So we actually have 4 locations, and you could write out your answer as all 4 of those plus 2 pi k. So you could take all of this space here and say, all right, well, one of them is pi/3 plus 2 pi k. That's the one in the first quadrant. One of them is 2 pi/3 plus 2 pi k. One of them is 4 pi/3 plus 2 pi k. And the last one is 5 pi/3 plus 2 pi k. There's definitely a more compact way of writing that you would probably appreciate, and I'll show you that now. So instead of all that, you could have jumped straight to theta is equal to, let's use this solution from quadrant 1, pi/3, and if I add pi to that, I end up landing right here. So I can say pi/3 plus pi k, and that will take care of the solutions in the first quadrant and the third quadrant. And then I could say 2 pi/3 plus pi k. And that will take care of the solutions that are in both the second and the fourth quadrant. So I think this is the best form of the answer. You could look at that in Desmos as well. Let's check that out. So if we go back over here and change the input equation to 4 cosine x squared and equals 1. So is that it? So here's pi/3, 2 pi/3, 4 pi/3, and 5 pi/3. So there's all 4 of the pi/3s between 0 and 2 pi, and then you can see that the same thing just happens again. Oops. There they all are with adding 2 pi to them. So here's pi/3, and if I just add pi, I get 4 pi/3, and if I'm at 2 pi and add pi, I get to 5 pi/3. So there you go. All right, last equation, number 39. This one's kind of tricky, so we'll go over it more in class, but I thought that you might appreciate having one on the video. The first step is to isolate the trig expression, which it already is isolated here. So before I can get to the theta/2, I have to get rid of the sine part of this equation. So when I'm done with my diagram, this equation is going to be what theta divided by 2 is equal to. So negative root 3/2 for sine, that means y is negative root 3 and the radius is 2. And so that's going to be in the third and fourth quadrant with another tall 30, 60, 90 triangle. So this, it's a pretty skinny looking one, and this, so that this y side or vertical side is negative root 3 and the radius is 2, and negative root 3 and the radius is 2. So the two angles where that happens are 4 pi over 3 plus anything that lands there, so 2 pi k, and 5 pi over 3 plus 2 pi k. So what's tricky about this is we're not done yet, because this side of the equation still says theta over 2. But if you think of this as kind of one big variable, let's say a. I can't really see that. Call this big variable a. If a is replaced with any of these angles, then this statement will be true. So if I say sine of 4 pi over 3, that's negative root 3 over 2. Sine of 5 pi over 3 is negative root 3 over 2. But if it just had an a there, we would be done, and this would say a is equal to. But what's really in the place here is theta over 2, so then before we finish, we have to take this equation and solve for theta by multiplying both sides of this equation by 2. So I'm going to take this whole set of solutions here and multiply by 2. So then my solutions to this are theta equals 8 pi over 3 plus 4 pi k and 10 pi over 3 plus 4 pi k. So I didn't go over this in class today because I just didn't think you were ready until after you had tried a few. But if you've understood 8 and 9 and done the other ones before 39, then I think that hopefully you're ready to understand that. Remember, when you're multiplying by 2 here, that you're really multiplying the fractions by 2 over 1. So that 2 over 1 times 4 pi over 3 is 8 pi over 3. Okay, so let's check to make sure that this works in Desmos and that you can see these solutions. I think this part is really cool. So we want to see, this is question 39, so sine parenthesis x divided by 2 and negative square root. If you just start typing SQRT, it turns into a square root of 3. Get out from under the root, use the slash for divide, and it'll drop you down, and so you can put that in there. And there's our first solution popping up already. 8 pi over 3 and 10 pi over 3. So what we got? 8 pi over 3 plus 10 pi over 3. Now the key is, are they 4 pi apart, the next set of solutions, or are they only 2 pi apart? Let's check. So 8 pi over 3 plus getting up to 20 pi over 3, the difference there is 12 pi over 3, which is 4 pi. So it was important to make sure that you double this. And maybe you would have an idea about that anyway, because if the function is theta divided by 2, you should know that the period of that is 4 pi anyway. So hopefully that makes all the pieces fit together. And there you go. Good luck on the rest of them.